A nice limit problem for exponential integral function. So this over here is that limit, and in this video let us try to prove this limit. If you don't know about exponential function, so this is basically exponential function for x is basically the integral from g to infinity of e to the power minus t by t dt. Okay, and now let's try to prove this statement. Okay, so for this one, since here's x, like I should have written over here x also, x as well. Yeah. Now we have a limit x tends to 0 of log x plus this integral from x to infinity of e to the power minus t by t dt. Now if we try to use integration by parts over here, we will have limit x tends to 0 and then log of x and plus, now if we use e to the power minus t times ln of t from x to infinity, yeah, and minus integral from x to infinity of, now this will be minus e to the power minus t and then ln of t dt. Okay, so limit x tends to 0 ln of x, and now this will just be e to the power minus infinity. At e to the power minus infinity it will just be 0, and minus it x e to the power minus x ln of x, and now this is plus integral from x to infinity of e to the power minus t ln t dt. Okay, now basically we have limit x tends to 0. If I take ln x common, I basically have 1 minus e to the power minus x plus x to infinity e to the power minus t ln of t dt. Now this is 0 times infinity, yeah, so you need to take limit for this expression. Now you need to use this is 0 into infinity. Let's try to use L'Hopital's rule. Okay, so we have limit x tends to 0 of ln x times 1 minus e to the power minus x. Let us first take to infinity by infinity form so that we can use L'Hopital's rule. Limit x tends to 0 ln of x by 1 minus e to the power minus x to the power minus 1. Now if we differentiate both of them, we have limit x tends to 0 1 by x by minus 1 1 minus e to the power x to the power minus 2. If we differentiate this expression, we will just have e to the power minus x, yeah, minus will be plus. Now to simplify this, what we can do is, first of all, take this to numerator. So 1 minus e to the power minus x whole square, yeah, and then minus x e to the power minus x. Okay, so now we can take this e to the power minus x to numerator, e to the power x, and multiply e to the power minus x to this this thing. Limit x goes to 0, we have e to the power x minus 1 by x, yeah, and then 1 minus e to the power minus x by minus 1. Okay, now this is standard limit, and this is just 1, and this is 1 minus 1, 0 by minus 1. Now 1 into 0 minus 1 is just 0. So I know that this limit is actually 0. So is equals to 0 plus and now at x equals to 0, this will be for integral from 0 to infinity of e to the power minus t ln t dt. And I think you should have heard of this integral. Yeah, if you haven't heard it, like it's just the derivative of gamma function at 1 is this integral e to the power minus t ln t dt, and we know that derivative of 1 is just minus Euler Macedonian constant, so this is just minus Euler Macedonian constant, and that's also the limit. So we basically use the integration by parts and use L'Hopital's rule to find this limit at 0, and evaluate this integral, and so we got the answer. So that was it. Yeah, that was it. Hope you enjoyed the video. Thanks for watching and look forward to seeing in the upcoming videos too.